Okay, so when you hear the name Einstein, what's the first thing that pops into your head? It's probably this picture, right? The crazy hair, the mustache, the face of pure untouchable genius. But that image, well, it's more of a caricature. In this explainer, we're going to peel back the layers of that myth and find the actual human being who completely upended our understanding of the universe. And it all starts with one simple thing: his childlike sense of wonder.
You know, the real key to understanding Einstein isn't some crazy complex equation. It actually goes back to a memory he had from when he was just 5 years old and sick in bed. His dad gave him a simple magnetic compass, and as he turned it around and around, that little needle always pointed north, moved by some invisible, silent force. He knew right then that there were deep, hidden mysteries behind everything. That feeling, that relentless curiosity, was the engine that powered his entire life.
And this really shows you the massive gap between the legend and the actual man. The myth, it gives us this one-dimensional genius. But the man? Oh, he was so much more complex. He was a patent clerk in Switzerland, looking at other people's inventions all day and then completely rewriting the laws of physics at night. He was a gifted violinist who found real solace and inspiration in music. And he was a refugee who fled Nazi Germany and became a powerful voice for civil rights in America. To really get how this patent clerk became a global icon, we've got to travel back to 1905 in Bern, Switzerland. Einstein is just 26 years old. He's got a day job, a young family, and he's seemingly a million miles away from the epicenters of scientific thought in Europe.
And yet, in this one single year, a year so incredible it's now called his Annus Mirabilis, his miracle year, he publishes 4 papers. Now get this, any one of those papers would have been enough to cement a physicist's place in history forever. Einstein dropped 4 of them.
The sheer range of his thinking here is just staggering. I mean, in one paper, he helps kickstart quantum mechanics by proving light can act like a particle. In another, he offers definitive proof that atoms are real, just by explaining why dust motes jiggle randomly in water. Then he completely demolishes centuries of physics by showing that time itself can slow down and space can contract. And then, almost like a little bonus track at the end of an album, he gives us the most famous equation in the world, E=mc², showing that mass is just an unbelievably concentrated form of energy. All in 1 year. It's just, wow.
So, if 1905 was a lightning-fast sprint of pure genius, what came next was a grueling intellectual marathon. Einstein knew his theory of relativity was still missing a huge piece of the puzzle. It worked perfectly for constant speed motion, but it didn't account for gravity. He was about to spend the next 10 years of his life building his true masterpiece.
Now, this wasn't some single eureka moment. It was a decade of hard, painstaking work. It all started with a simple thought experiment back in 1907. He imagined a man in a falling elevator. For that brief moment, he'd be weightless. So maybe, just maybe, gravity wasn't a force at all. Maybe it was indistinguishable from acceleration. By 1911, that idea led to a prediction you could actually test. A massive object like our sun should literally bend the fabric of space and therefore bend the path of light that passes near it. Finally, in 1915, he put it all together. Gravity is the curvature of space-time itself.
It's such a mind-bending idea, isn't it? I mean, how on earth could you prove something so bizarre? You can't see space-time. You can't hold it. So how do you go about measuring if it's bent? Well, the answer was just as elegant as the theory itself.
That's right. You wait for the moon to pass directly in front of the sun, creating a few precious minutes of daytime darkness. In that darkness, you can take pictures of the stars that appear right next to the sun's blocked-out disk. Then, you compare those pictures to photos of the very same stars taken months earlier at night. If Einstein was right, the sun's immense gravity would warp space-time, bending the starlight and making the stars appear to be in a slightly different position. In 1919, a British astronomer named Sir Arthur Eddington set out on an expedition to do exactly that. The results were in. The stars had shifted, and they had shifted by the exact amount Einstein's mind-bending equations predicted they would. It was a total vindication. Literally overnight, Albert Einstein went from being a well-respected physicist to being the most famous scientist in the world. I mean, that headline says it all. Isaac Newton's universe was officially overthrown, and Einstein's had taken its place.
All of a sudden, Einstein had this massive global platform. And you know what? He wasn't afraid to use it. He knew his fame gave him a voice that could reach far beyond the halls of science, and he felt it was his duty to speak out on the huge moral and political challenges of his time. So, in 1939, Einstein, who was a lifelong and deeply committed pacifist, someone who believes war is just fundamentally wrong, faced an absolutely agonizing decision. Other scientists, who had also fled the rising tide of fascism in Europe, came to him with a terrifying warning. They believed Hitler's Germany was trying to build an atomic bomb. They begged him to use his fame to warn President Roosevelt. Terrified of a world where the Nazis got the bomb first, he signed the letter. And that letter was one of the key things that helped kickstart the Manhattan Project.
And it was a decision that would haunt him for the rest of his days. Years later, he called it the one great mistake of his life. Can you imagine the burden? The man who hated war had, out of fear of an even greater evil, helped to unleash the most destructive weapon in human history.
Einstein's conscience was a powerful force in his life. He renounced his German citizenship the moment Hitler came to power in 1933 and eventually settled in Princeton, New Jersey. But when he got to his new home, he was absolutely horrified to see the parallels between the anti-Semitism he had just escaped in Europe and the deep systemic racism that Black Americans faced every single day.
And he did not stay silent about it. Not at all. He famously called racism America's worst disease. He joined the NAACP. He spoke out constantly against segregation. For him, it was personal. He saw a direct, ugly line connecting the persecution of Jews in Germany to the discrimination against Black people in his new country, and he felt a profound obligation to stand with them.
Okay, so as we get to the final chapter of his life, we see a really different, almost ironic side of this great revolutionary. For all his incredible success, Einstein's later years were marked by a kind of intellectual loneliness. The man who overthrew Newton's physics found himself unable to accept the next great revolution, a revolution he had actually helped to start.
This is probably his second most famous quote, and it really gets right to the heart of his issue with quantum mechanics. This new theory described a universe that, at its most fundamental level, was governed by pure chance and probability. You could never know for sure where an electron would be or what it would do next, and Einstein, he just hated that idea. He believed, deep in his soul, in a universe of cause and effect, of perfect order.
So you basically have these two dueling visions of what reality even is. In Einstein's view, the universe was like a magnificent, intricate clock. It's complex, sure, but if you could just figure out all the rules, it would be completely predictable. But the quantum view? It said the universe was much more like a casino, where randomness wasn't just a possibility, it was woven into the very fabric of existence. For decades, Einstein came up with brilliant arguments to find a flaw in quantum theory, but time and time again, the theory held up.
So he dedicated the last 30 years of his life to this single grand quest, to find what he called a unified field theory. He was searching for one master set of equations that could describe both gravity and electromagnetism, one beautiful, elegant framework that would prove his deepest conviction, that there was something simple and deeply hidden behind it all. He never found it. And that really brings us to his ultimate legacy, because that hunt for a unified theory, what we now call a theory of everything, is still the absolute holy grail of modern physics. It's the grand dream that he left for the rest of us to chase. So when we look back at the man behind the myth, we're left with this question. Was his true, lasting genius in the incredible answers he gave us, or was it in revealing a whole new universe of questions that he taught us how to ask?